shift. So we're going to move the graph to the left or to the right based on whatever's inside those parentheses. And we can do this by transformations and key points. So we're first going to start off with transformations. Okay. So first up is find the amplitude, period, and phase shift of a sinusoidal function and graph it. So here we are given y equals 3 times the sine of 2x minus pi. Okay, to see the phase shift, we're going to have to manipulate the inside of the sine function. And what I mean by that is all we're going to do is factor out this 2 from the 2x minus pi. So when I do that, the function is going to look like this. 3 times the sine, and I'm going to put brackets just to be neat. And I'm only factoring it from the inside. So all of this is still remaining inside the argument of the sine function. So when I factor this 2 out, I'm going to get 2 times x minus pi over 2. So remember, when you factor something out, it's essentially dividing it from each term. So if you want to check if you factored correctly, just distribute this 2 back in, and we'll get back to the original statement inside the sine function. Okay. And again, the reason we're doing this is so we can see the phase shift and the rest of the transformations, which is what we're going to look at right now. Okay. So based on transformations, what does this 3 do?
Vertical stretch.
Vertical stretch. Good. What does the 2 do?
Horizontal compression.
Horizontal compression. And then the x minus pi over 2 is a horizontal shift. Which way?
Right.
Good. So this would be a horizontal shift to the right by pi over 2 units.
So basically your first step is to try to get the x or the variable with a coefficient of 1.
Exactly. So you want to factor out whatever the coefficient of x is, so you can see the actual phase shift going on. And it also shows you the rest of the transformations. So the 2 is a compression, horizontal compression, the 3 is a vertical stretch, and the x minus pi over 2 is a shift to the right by pi over 2 units. Okay, I guess I should put the other ones in here. Hang on. This would be a vertical stretch by 3, and this would be a horizontal compression by 1/2. Okay, and I have this nicely set up. On the left side are the parent function's coordinates. So what we're going to do is take these coordinates and transform them by the given transformations in this problem. So the x values are going to take some work. We have some fraction work to do, but the y values are going to be easy. So let's start with that. So these y values, lucky for us, you're just going to multiply them by 3. So -3, 0, 3, 0, -3, 0. Okay. And now the x values, let's do some work. Oh boy. So this means we're going to take negative pi over 2, multiply it by 1/2, and then add pi over 2. So we have negative pi over 2 times, or actually I should write it as it's written there. 1/2 times our x value of negative pi over 2 plus pi over 2. If you reduce all of that, that gives me negative pi over 4. So that gives me negative pi over 4 plus pi over 2. Now you need to get a common denominator of 4. So you multiply that by 2 over 2, and you get negative pi over 4 plus 2 pi over 4. So this is going to give me pi over 4. All the lovely fraction work you can handle, right? And we do it again. Next is 0. 1/2 times 0 plus pi over 2. Hey, that one's nice. That gives us pi over 2. Then again, 1/2 times pi over 2 plus pi over 2. That's going to give me pi over 4 plus pi over 2. Get your common denominator, and you're going to get pi over 4 plus 2 pi over 4, giving me 3 pi over 4. Next is pi. 1/2 times pi plus pi over 2 gives me pi over 2 plus pi over 2, which gives me 2 pi over 2, or just pi. All right, still moving. 1/2 times 3 pi over 2 plus pi over 2 gives me 3 pi over 4 plus pi over 2. Again, get your common denominator of 4, and 3 pi over 2 plus 2 pi over 2, 2 pi over 4 gives me 5 pi over 4. And then last, 1/2 times 2 pi plus pi over 2 gives me pi plus pi over 2. Get a common denominator of 2, and 2 pi over 2 plus pi over 2 gives me 3 pi over 2. Woo-hoo. So these are the x values we are looking at. Okay. Any questions on all that fraction math? Let's hope I got it right by going turbo speed. Okay. So I'm going to plot my x values down below. You see that I don't have a 0 for my x values, and that's okay. I can label this graph however I want. So what I'm going to do is start with the left side and make this pi over 4. And you can start wherever you want on this graph. I'm just going to always start with the point on the left side. Pi over 4. I'm going to make this pi over 2, and then 3 pi over 4, pi, 5 pi over 4, and then 3 pi over 2. And then the highest we go is 3. So there's 3 and negative 3. Okay. And now plot. Pi over 4, negative 3. I can make that bigger. There we go. And then pi over 2 and 0. And then 3 pi over 4 and 3. And then 0. And then negative 3 and then 0. So here's what we look like. There's our graph. And now all we have to figure out is the amplitude, period, and phase shift. So what is the amplitude of this graph?
3.
3. What is the period of this graph? You put 2 pi over. What number is in front of the x minus pi over 2?
2.
2. It's always over omega. So it's 2 pi over 2, so we get a period of pi. And then my phase shift is x minus pi over 2, or a horizontal shift to the right by pi over 2 units. And there we go. So essentially what we're doing by transformations, when we're given this trig function of sine of omega x minus, oh, that fancy one is phi plus b, what we're doing to graph this by transformations is we're factoring omega out from omega x minus phi. So you get y, gross. You get y equals a times the sine of omega times x minus phi over omega plus b. That's all we did right there. Any questions on this one?
So the phase shift is going to be phi over omega every time?
Every time.
Cool.
What the heck is phi?
It's just another Greek.
How do you spell phi?
I think it's Fi or Phi, one of them.
Cool.
Could be getting that wrong too.
It's like VI. VIE.
Or circle with the line over W. There you go.
True.
All right, everybody go with this one?
Yes, sir.
Yep.
Just got to handle all that fraction math, right? Okay. Next one. Another one by transformations. This time it's cosine. So let's go ahead and rewrite it. What number am I going to factor out in the inside?
4.
4. So this will become 2 cosine, bracket to be fancy and neat. I factor out the 4, and what am I left with on the inside?
X plus 3 pi over 4.
There you go. X plus 3 pi over 4, close bracket, and don't forget that 1 out there. Okay, let's label transformations. What does that 2 do in front?
Vertical stretch.
Vertical stretch.
Vertical stretch. Good. What does this 4 do?
Horizontal compression.
Horizontal compression. By what factor?
1/4.
By 1/4. Don't forget to add it on that one. By 2. And then we have a horizontal shift or a phase shift. Which way?
Left.
So left by 3 pi over 4.
Good. Horizontal shift left by 3 pi over 4. And then the very last one is what type of transformation?
Vertical shift.
Vertical shift. Which way? Up or down?
Up by 1.
There we go. Woohoo! So there are the parent function coordinates for cosine. And now we're going to transform it. So this means for my x values, I multiply them by 1/4, and then I subtract 3 pi over 4. For my y values, I multiply them by 2, and then I add 1. All right, let's get started. So 1/4 times negative pi over 2 minus 3 pi over 4. So that's negative pi over 8 minus 3 pi over 4. Get a common denominator of 8, and you'll get negative pi over 8 minus 6 pi over 8, which will give us negative
7 pi over 8.
7 pi over 8. And then 1/4 times 0 minus 3 pi over 4. I like the zeros. You get negative 3 pi over 4. Okay. And then 1/4 times pi over 2 minus 3 pi over 4. You get pi over 8 minus 3 pi over 4. Multiply that by 2 over 2. Pi over 8 minus 6 pi over 8, you get negative
5 pi over 8.
5 pi over 8. And then 1/4 times pi minus 3 pi over 4. You get pi over 4 minus 3 pi over 4, giving me negative 2 pi over 4, right? Which is negative pi over 2. Yeah. Pi over 4 minus 3 pi over 4, negative 2 pi over 4, which is negative pi over 2. And then you get 1/4 times 3 pi over 2 minus 3 pi over 4. That's 3 pi over 8 minus 3 pi over 4, common denominator of 8. 3 pi over 8 minus 6 pi over 8. Negative 3 pi over 8. All right, almost there. 1/4 times 2 pi minus 3 pi over 4 gives me 2 pi over 4, or actually, I'll leave it at that, right? Yeah. We'll leave it as 2 pi over 4 minus 3 pi over 4 gives me negative pi over 4. Ooh. 3 pi over 4, and then boom. Aha. Okay, cool. Now the y value is the easy part. 2 times 0 is 0. 0 plus 1 gives me 1. 2 times 1 is 2. 2 plus 1 gives me 3. 2 times 0 plus 1 gives me 1. 2 times negative 1 is negative 2 plus 1 gives me negative 1. 2 times 0 plus 1 gives me 1. And then 2 times 1 plus 1 gives me 3. There we go. We can now graph our function. So this will be negative 7 pi over 8. I'll start here. Negative 7 pi over 8. And then I'll have negative 3 pi over 4. And then negative 5 pi over 8. Negative pi over 2. Negative 3 pi over 8. And negative pi over 4. Highest we go is 3. Lowest we go is negative 1. Yeehaw. All right. Negative 7 pi over 8, you're at 1. Negative 3 pi over 4, you're at 3. Negative 5 pi over 8, you're back at 1. Negative pi over 2, we're down at negative 1. And then negative 3 pi over 8, back at 1, and then 3. There we go. A little more curvy though, right? Okay. So what is our amplitude here?
Three.
What's the number in front of cosine?
2.
2.
2. Period. What's our period? 2 pi over what number?
4.
4. Good. Which means we get pi over 2. And what's our phase shift? X plus what?
1. No, 3/4.
X plus 3 pi over 4. There you go. All right. So those are phase shifts by transformations. Any questions on that process? What's up?
Just real quick, can you do how did you do the period again? I don't know why I can't see it.
It's always 2 pi over omega. What's the value of omega?
3 pi over 4.
That's the phase shift.
4. That's
you-
okay.
There you go. Okay.
That's right. Omega is always going to be factored out pretty much.
Exactly.
Okay.
Okay. So now those were 2 by transformations. We will do one by key points. Ooh la la. Okay. So the graph of y equals a sine of omega x minus phi plus b may also be written as a times the sine of omega times x minus phi over omega plus b. Basically what we did, we factor out the omega and graphed it. Where b is greater than 0 and c are real numbers, there's one b. Oh yeah, I keep forgetting to change those. It should say where omega is greater than 0 and phi are real numbers. The graph will be a sine curve with amplitude A. As omega x minus phi varies, or as the phase shift varies from 0 to 2 pi, one period will be traced out. So when we do this by key points, we need to know what the beginning of the phase shift is and what the end of the phase shift is. So to find the beginning of the phase shift, you will set the inside of your function, the omega x minus phi, you'll set it equal to 0 and solve for x. This will tell us the beginning of our phase shift. And then when you want to know the end of your phase shift, you will set omega x minus phi equal to 2 pi and solve for x. Now, if this was for tangent or cotangent, you would set them equal to what?
0 and pi.
There you go. So for tangent and cotangent, for the end, the beginning shift's the same. For the end shift, you would take omega x minus phi and set it equal just to pi, because that's the period of tangent and cotangent. Okay, in case you ran across those. The number phi over omega is called the phase shift. Okay, cool. Let me change these real fast. That should be omega, and that should be phi. There we go. Okay, let's do this by key points. So we have y equals 2 cosine 3x plus 2. And when you do key points, we don't have to factor anything out. Life is good, but we have a long process in front of us. So what is the amplitude of this function?
Two.
2. What is the period of this function?
Two pi over 3.
There you go. And now let's find the beginning phase shift and the ending phase shift. So the beginning phase shift, I'll write it up here. Phase shift begin, which means we take 3x plus pi over 2, set it equal to 0, and solve for x. You'll move pi over 2 over, and then you'll divide by 3. So when you divide by 3, it's the same as multiplying by 1/3, which means you'll get x equals negative pi over 6. this is the beginning of our phase shift. And now we want the end of our phase shift. So we take 3x plus pi over 2 and set it equal to 2 pi and solve for x. So again, you'll move that pi over 2 over. And then we will divide by 3, but let's go ahead and put this as one whole fraction together. So you'll do 2 pi over 1, get a common denominator of 2, which will give you 4 pi over 2 minus pi over 2. What would that give me?
3 pi over 2.
3 pi over 2. And then you multiply, you divide by 3, which again is the same by multiplying by 1/3. And we'll get our end shift at x equals pi over 2. All right. Now we know where our phase shift begins and our phase shift ends. Any questions so far?
So aside from that, that makes the
what? Where'd you go?
I think he's dead.
Yep, you're cutting out, Luis.
Sorry. So that makes the start of the phase shift. Okay, so that's the start and the end of the phase shift, but and then the graph goes back to normal, or that's just like
No. So the graph will never go back to, like, if you're saying normal, like parent function coordinates normal, no, because
okay, I didn't think so, but
yeah, because if you look at this function we're working with, look at all the transformations on it.
yeah, and that's
But it'll
just
repeat itself, right?
graph.
Exactly.
But like, what does the beginning and end of the phase shift like mean to the graph? That's just like the entire period of the phase shift.
Exactly. So it's like it's the cycle of when it will repeat itself.
Okay.
So it'll repeat itself from every interval of negative pi over 6 to pi over 2. So
Gotcha.
it's telling you where it begins, because since it's a horizontal shift to the left, this means you take the cosine function and you shift it to the left. So you mess up its cycle, right?
So what does the period being 2 pi over 3 mean then? That's just
That
like
is just, well, that's going to come into play in a second, but that is just the
compression.
It's the compression and how it will repeat itself. So don't worry, we'll get there.
Okay, gotcha.
Okay, so now, since we know where we begin and end, this creates our interval for this graph. So the interval for our graph is now going to begin at negative pi over 6 and pi over 2. But we now have to take this interval and break it into 4 sub-intervals like we did for the last key points. So that means in order to find each sub-interval, we need to know their length. So what we did last time is we took the period and divided it by 4. And again, the reason we divided by 4 is because we're only making 4 sub-intervals. So I'll write that down again. So over here, we'll say, we'll have length of sub-intervals, which means you take the period and divide it by 4. Our period is 2 pi over 3. So this means we take 2 pi over 3 and divide it by 4, which means we multiply by the reciprocal. My pen does not want to write. 2 pi over 3 and multiply it by 1/4, which means the length of each sub-interval is going to be pi over 6, right? Because that's 2 pi over 12 or pi over 6. Okay. So what we do with that information is we make our 4 sub-intervals within the main interval. So here's where we're starting. Number 1. We start at negative pi over 6. And then I add a subinterval length of pi over 6. So what would negative pi over 6 plus pi over 6 be?
Pi.
What? Negative pi over 6 plus pi over 6 would give me
0.
0. And then we do the second subinterval. What's up?
Why are you having a negative pi over 6?
Because that's where our phase shift begins.
Okay.
And then you have 0, and you add another pi over 6. Well, what's 0 plus pi over 6?
Pi over 6.
Pi over 6. There's the third one. 3. You start at pi over 6, and you add another pi over 6. That gives you 2 pi over 6, or
Pi over 3.
Pi over 3. And then our fourth and final subinterval. You start at pi over 3 and cheat code this. You're going to add another pi over 6. So just go back to this and add another pi over 6, which gives you 3 pi over 6, or pi over
2.
2.
You could also just look at the end, the very end one, right? And try that.
Oh, yeah, that works too. Whatever. Don't cheat my cheat code. Because, well, you could do that, but what if your math was messed up, right? What if like this was what if that was incorrect, you know? But I guess you figured it out when you graph it. Okay, so to make sure you did these right, like Ethan said, this endpoint of your last subinterval should match the endpoint of your main subinterval. And since those match, we did our work correctly. Oh man, if this was transformations, we'd be done already, right? Okay, so now remember that these are x values. So now we actually have to find the y values. So we're going to take all of these x values and plug them into the function above. Ugh. So you're going to have when x equals negative pi over 6, y equals, and then when x equals 0, y equals, and when x equals pi over 6, y equals, and then we have when x is pi over 3 and pi over 2. And pi over 2. Well, it's a good thing we have calculators, and I taught you that trick last time, right? You can knock these out real fast. I'll just use Desmos really quick. Here we go. Make sure you are in radians. Yep. And I'll type this function in 2 cosine 3x plus 2. Close parentheses. Not plus 2. Pi over 2. 3x plus pi over 2. And then table, and here we go. Let me zoom in on these guys. I'll type these in. Negative pi over 6, 0, and pi over 6. Look how nice that is. I get 2, 0, negative 2. And then the last ones, pi over 3 and pi over 2. All right. Pi over 3 gives me 0. Pi over 2 gives me 2. Bam. Desmos for the win. Here are the coordinates we're going to graph. Yeehaw. So let me set this up. I have negative pi over 6, 0, pi over 6, pi over 3, pi over 2. Highest is 2. Lowest is negative 2. And then negative pi over 6, we're at 2, 0, 0, negative 2, 0, 0, and 2. So we would look something like that. And boom, that is phase shifts by key points. Any questions on that?
And we're only doing this for sine and cosine so far?
So far, I think I have a couple examples of tangent on, or one example of tangent on the next page.
And then like cotangent and the other functions, are those going
And
to be?
cosecant and secant, yes. So you can apply that to all of those trig functions.
Okay, cool.
Yeah, so if you like key points, stick with key points. But yeah, so stick with key points, or if you like transformations, stick with transformations. Transformations are so much faster. Look at that. That took like 30 minutes. All right. Everybody good with this one? All right. All right. All right. Look at this. Here we come across tangent. Woo. And do I have a graph down there? I do. Oh, that's the last one. Okay. All right. So I'm going to do this by transformations, but we have enough time. I can show it by key points if you want. So let's start with tangent and let's manipulate this. What am I going to factor out?
4.
The 4. Y equals tangent. Take the 4 out and you'll have x minus pi over 4. Perfect. Okay. What does the 2 do?
Vertical stretch.
Vertical stretch by 2. What does the 4 do?
Horizontal compression.
Horizontal compress by 1/4. And then last, the x minus pi over 4 is a
Shift to the right.
horizontal shift right. Oh my goodness. Right, by pi over 4. Okay. All I need to know are parent function coordinates for tangent, which means that I'm going to choose, let's see, for x and the tangent of x, I can go from, let's just do negative pi over 2, and that'll give me a vertical asymptote. And if I do, let's see, negative pi over 2, oh yeah, and then negative pi over 4, 0, pi over 4, and pi over 2. Okay, so tangent is undefined at pi over 2, but then will be negative 1, 0, 1, undefined. All right, so now when I transform this, my x values, I will multiply by 1/4 and then add pi over 4. My y values, lucky us, I just have to multiply them by 2. Okay, so first up is negative pi over 2. So that'd be 1/4 times negative pi over 2 plus pi over 4. That'd be negative pi over 8 plus pi over 4. Get a common denominator of 8, and negative pi over 8 plus 2 pi over 8 gives me pi over 8. So there's the first one. Then next is 1/4 times negative pi over 4 plus pi over 4. You get negative pi over 16 plus pi over 4. Get a common denominator of 16. And negative pi over 16 plus 4 pi over 16 gives me 3 pi over 16. Okay, doing good. And then you get 1/4 times 0 plus pi over 4. Hey, that's nice. You just end up with pi over 4. Zeros are the best. And then next is 1/4 times pi over 4 plus pi over 4. You get pi over 16 plus pi over 4. Common denominator 4. Pi over 16 plus 4 pi over 16. 5 pi over 16. All right, last coordinate. 1/4 times pi over 2 plus pi over 4. You get pi over 8 plus pi over 4. Common denominator of 8. Multiply by 2 over 2. And that's pi over 8 plus 2 pi over 8. 3 pi over 8. Yeehaw. Those are all your x values. And now your y values, just multiply them by 2. 2 times undefined is double undefined. 2 times -1, -2, 0, 2, undefined. Yeehaw. And now we just graph it. I should show this one by key points because you're gonna get, I think, different x values. So we're gonna have to see this one by key points as well. All right. So here's pi over 8, 3 pi over 16, pi over 4, 5 pi over 16, and 3 pi over 8. Highest is 2, lowest is -2. Vertical asymptote at pi over 8 and 3 pi over 8. And then just graph the rest. So let's see, 3 pi over 16 and -2, 0, 2. And here is tangent. And of course, it would repeat itself everywhere else. Okay. So let's run through key points real fast. I'll rewrite the function y equals 2 tangent 4x minus pi. Amp, tangent doesn't really have an amp, but we'll put 2. It's more of a stretch. And then period. Here's where we have to be careful. Since it's tangent, are we using 2 pi or pi?
Pi.
Pi. So period will put pi over omega. So we're going to get pi over
4.
4. There we go. And then beginning phase shift, begin. We do 4. Oh my goodness. My pen, don't give up on me. 4x minus pi equal to 0. 4x equals pi. x equals pi over 4. And then phase shift end. And again, be careful here. Since it's tangent, you must set it equal to pi, not 2 pi. Here you'll get 4x equals 2 pi, divide by 4. X equals 2 pi over 4, which is pi over 2, right? So there's the beginning and there's the end. All right. Next is your intervals. So I'll just put that there. So your main interval is from pi over 4 to pi over 2. And then the length of your intervals is going to be, of course, the period over 4, which means you take pi over 4 divided by 4. That'll give you pi over 16. And now we start. 1, we start at pi over 4 and add a pi over 16. So pi over 4 plus pi over 16, common denominator of 4. 4 pi over 16 plus pi over 16, 5 pi over 16. 2, start at 5 pi over 16, add another pi over 16. That'll give you 6 pi over 16. 6 pi over 16, which if you reduce by 2, 3 pi over 8. 3, start at 3 pi over 8, and then add a pi over 16. Cheat code, just add a pi over 16 to the last one, and you'll get 7 pi over 16. All right, and then 4, 7 pi over 16, add another pi over 16, you'll get 8 pi over 16, which is pi over 2. Match and match. Okay. Oh my goodness. Crazy. And then plug these into the function. So I'll say points. And x equals pi over 4. X equals 5 pi over 16. X equals 3 pi over 8. Y equals, y equals, y equals. And then x equals 7 pi over 16. And x equals pi over 2. Ooh la, ooh la la. I'm just going to use my calculator here. Faster.
What did you mean when you originally you said like the x's are going to be different?
So you see that unless they're matching up, but do some of my numbers on that XY chart match this one? You see I have a pi over 8 and a 3 pi over 16. My only numbers that match are pi over 4, 5 pi over 16, and 3 pi over 8. So there's going to be similar ones, but I'm going to have different x values using transformations. The only different ones are these two. But I'm sure my math lab is going to be nice. We can even look at my math lab problem after this to see what it wants. Okay. I am in radians and then table. And then I have 2 tangent 4x minus pi. Ask, here I go, pi over 4, 5 pi over 16, and then 3 pi over 8. So this is going to be 0, 2, and then 3 pi over 8 gives me 2e to the 12th. Oh my goodness. Oh, that means it's undefined. And then 7 pi over 16, I get -2, and then pi over 2, I get 0. So with key points, we're just a little bit different, but it's not too bad. When I graph this, I have pi over 4. So I'll just say here's pi over 4, 5 pi over 16, 3 pi over 8, 7 pi over 16, and pi over 2. So this is saying my vertical asymptote is at 3 pi over 8. And then for the rest, at pi over 4, I'm at 0. 5 pi over 6, I'm at 2. So we would look something like this. And then 7 pi over 16, I'm at -2, 0, and it would look something like that. So definitely some differences, but it's the exact same graph, just on different intervals. Whew. All right. Now let's see what your homework wants. Let me see. All the same, amplitude, amplitude, amplitude. Write an equation that has that. Find the amplitude. And graph the function. Okay, so these aren't bad. All right, let me share this screen now. Or maybe they are bad. Share screen, yes. And then this one, okay, let's see. Okay, find the amplitude, the period, and phase shift. So we we know amplitude is 6. The period is 2 pi over 3. The phase shift is going to be, if you factor 3 out, it's gonna be, I think it just wants the number. So it'll be pi over 6. Are you guys seeing the my math lab screen?
Yeah.
Okay. Factor the 3 out. X plus, oh, is going to be negative, right? Negative. There we go. Negative. And then graph it. Oh boy. All right. So we need a point. Oh, great. I guess this is where key points would come in. So
Too bad.
right? Key points or transformations. Let me see. I could get that faster by transformations. Let me annotate that. So for just regular sine, I have, let's just do 0 pi over 2. I think I just need, well, I need to be able to graph it too. So 0 pi over 2 pi. So 0, 1, 0. Transform. I have 3 times x plus pi over 6 and the -6 out front. So that means that my x values get multiplied by 1/3 and then subtract pi over 6. My y values get multiplied by -6. Gross. All right. Does this have a pi over 6 for us to graph? Because if I plug in 0, I get negative pi over 6. And it does not, right? 1, 1, 1. 0, negative pi over 6. Why is this giving me whole numbers? It's broken. So you take the 3 out, that's 1/3. You subtract pi over 6.
Is it going to make you start at the origin and then enter it like that with the chart thing?
Maybe. Well, we need to find a point. That's why I'm looking at transformations right now. Because if I choose 0, 1/3 times 0, 0, and I get negative pi over 6 and 0 for my y value.
I think that regardless of where you put it, it just starts it at the origin.
Yeah, I think
Does it?
try that. I think you might have to enter the stuff. It might it might do
Okay.
that thing where it shifts you.
Hey, well then that's good for you guys. If no matter where you click, it starts it, right?
Yeah, like 10 times easier.
Thank
Let's see.
God.
Clear. Okay, then you don't have to find a point. Nice. Let's see. I'll click up here. All right. So it gives you the regular sine function. Hey, that makes your life easier then. So amplitude is 6. So drag this lovely bar. Period is 2 pi over 3. Man, you guys have it easy. No vertical shift. There is a reflection over the x-axis. And then my phase shift is just negative pi over 6. Let's see what it does with that. And done. And save. And check. Oh, you guys have it easy. You don't need to find a point then. My goodness. Me stressing over that. Let's try another one. Okay. What is amplitude? 2. What is period? 2 pi over 6 or pi over 3. What is phase shift? Negative pi over 12. Okay, graph it. This is cosine. Plot a point anywhere. My goodness. Amplitude is 2. Period is pi over 3. Vertical shift, no vertical shift. Phase shift is negative pi over 12. And then there's no reflection. So that's done. Save and check. And oh my gosh, wow. Too easy, guys.
Hey, we're not complaining, all right?
I know, right? I am now. Okay.
It needs to be harder.
Right.